Okay, so I would like to introduce myself. My name is Rebecca Anderson, and this is my computer science orientation final project. I will try not to speak too fast, even though I have a habit of doing so, and let's go ahead and get started. So here is my first slide. It is all about my introduction. So pretty much there was a lot of stuff we went over in class this semester, and a lot of that information was new. Some of it was not so new, but the way it was presented and the information I got from it was certainly new. Uh, some things that were completely new for me was the algorithms and data structures. I knew about programming languages and a lot of how they kind of functioned. I got a lot more detail on that in this class. Computer architecture, again, I had an idea. Again, I got a lot more detail in this class. Um, we also went over operating systems, networking. Networking is interesting because it seems like a very simple structure that is set for it, except it's very much not. Like if you actually had to do the Cisco certification or anything else that is very networking based, it is incredibly complicated because everything needs to talk to everything, and that's a very hard thing to guarantee for all the various little different languages and way people do things all over the place. It's hard enough to get my cell phone to talk to my computer, as an example. Um, Databases, uh, theory of computation. I'm always pretty bad about theory. I'm very hands-on about stuff, but this is actually pretty interesting, and a lot of it wasn't as bad as I thought it was going to be. And software engineering, of course, was a huge part. And of course, the types of class positions you can get in and other things like that. So now let's go to. So one of the things that I wanted to talk about today is the programming languages. So for the most part, yeah, I knew about Python, I knew about Java, C++. PHP was something that was very new to me. I don't think I've ever heard that name before in the entirety of my life. JavaScript, I did know, never heard of Ruby. And of course, there was other things that were other languages we discussed that's not here. But then learning the differences between libraries and languages, such as React is a library, it is not a language. It uses other languages connected to its library to make things a little bit easier for you to program, usually websites and apps. But learning about that was pretty interesting because, again, I was not very knowledgeable about that. And then it turns into okay, so you have all these languages, like, kind of what are they? Can they be grouped together? And then we get into the next section, which is like, what is the type of language that we're talking about here? And so here we have high level languages, excuse me, high level languages and low level languages. And there's going to be a lot more to discuss. Like we had whole classes all over the place about this. It was very informative. But essentially, high level languages such as Python, JavaScript, Ruby. Usually, they're much easier to read and debug and write. Um, they're pretty abstract with complex details and memory management and allowing you to focus on solving the problem rather than, how to write it the right exact way. Development is typically really, really fast when you're using that type of language because it's much more uh, ergonomic, kind of, I guess you could say, in a way. I guess thoughtfully ergonomic. The con is the abstraction that comes with the cost. So because it's so abstract, the computer has a hard time decoding what you're trying to say and what you mean. And so the hardware overall is a little slower. When it comes to low level languages like C and assembly, the pro is the maximum performance and direct control over the hardware because it's speaking its language, essentially. Um, Game engines, I'll work through that, various operating systems and embedding systems, uh, because, at that point, speed is paramount. If you're gaming, you don't like lag, you want things to move Otherwise, you kind of hate the game. A con is it's extremely difficult to learn, right? Because it's the computer's language. You really got to be technical about it, and the memorization of what goes where and how and exactly how this particular thing should be said to get this particular outcome is much more difficult to do. Uh, then we turn to a few other types of languages, such as the statistically typed languages like Java, C++, and Rust. Um, these type happen at compile time. So they work together, compile time, which catches many of the errors before the program ever runs. So it goes through before the program runs, so that way if there's an error, it can just come up with the error really, really fast. The problem is that it's pretty expansive and very, very rigid. Like it's not, you can't really change anything about it. Everything's very specific, and getting all of the every type of variable and everything's perfect is very difficult. Then you go to dynamic type languages such as Python, JavaScript, uh, compiled. Yeah, dynamic type languages, I'm sorry, such as Python, JavaScript, PHP. These are a little more flexible, and they're easier to write or concise to write. You don't you don't need to declare variable types, which makes up for faster prototyping and scripting overall, which is what every which is literally what you want when you're doing a huge project or even a small project for the most part. Errors are the type of mismatches that are only discovered at the runtime, which means it can lead to crashes in production and it's harder to debug. So that kind of is not good. Then you have compiled languages. Trying to get through these a little bit. Compiled languages like C++, Go, Rust. Um, these ones are directly coded into the machine before the execution. So the results of the programs that run very fast and highly optimized compilation step also catches syntax errors pretty early, which is really what you want it to do. The problem is the debug cycle is incredibly slow. Um, the development is much less fluid because you can't debug it fast enough because it takes forever for it to show. And you need to recompile for every different platform. So if you're on Linux, Mac, Windows, Android, whatever, since each one is different, you have to do it differently for each one, and that can be a pain. Then you have the interpreted languages. Sorry, just checking my time real fast. The interpreted languages, such as line by line, code is executed line by line and is interpreted at runtime. It eliminates the compilation steps because it's as you're doing it, it's doing it itself. The problem is that it adds a layer of overhead, making these languages really, really slow, other than compiled languages where it can just kind of read it all at once and go. Um, then some honorable mentions like the language with large ecosystems or JavaScript and Python, or languages with small and niche ecosystems like Lisp and Haskell. Um, so the next part, what is binary? So binary is how the computer talks to itself. It's a very simple two decimal or base two number system. It doesn't, it uses a decimal system of which there are 10 digits, 0 through 9. Um, yeah, 0 through 9. And binary only uses the two digits of 0 and 1. So if you want a number of 120 something, it's going to be, I don't know the actual binary number because I didn't do the math for it, but it'd be like 011000101 type situation going on. Um, so how is so and then of course they count by the powers of two, things like that. So two to the zero, two to the one, and of course if it's two to the zero, the answer is going to be one because I do remember the math on that, which was pretty good, which is 2 divided by 1/2, which is going to be 1. And if it's 3, then it's 3 divided by 1/3, which is 1, uh, and things like that. Holy goodness. I'm running out of time now. Let's see. So you count binary in a very simple way. It doesn't take a lot. Uh, it's it's a very simple system. You have two binary digits, 0 and 1. When you go past 1, you have to roll over to the next wheel or to the next section. When you so you start with 0 is 1, 1 is 2 is 1, 3 is 1 0, 4 is 1 1, 5 is 1 0 0, and so on and so forth. It's pretty simple for the most part. Then you have, my goodness, why computers use it. So computers use binary because that's just how their operation system works. They use transistors which go on, off, on, off, on, off, and with zero being off and one being on, or vice versa, it makes it very easy for it to read the system and translate the data across. Uh, across. And when it comes to programming allows you to take all the data and organize it in a way that's easy for people to read and easy for people to use. Um, so it does a lot of data cleaning, data organizing type situation. Then you have binary and programming to networking. So binary and programming to networking is very interesting because, I mean, everything works off of binary. Everything works off of the on and off system. Everything works in perfect communication with binary. So using something else doesn't make any sense. And for programming, you got to organize all this information in a packaged way that's easy for people to access from whether you're going into Amazon or wherever else, so that way you can easily see and disseminate information very quickly and also make actions and do actions very quickly. Now, the security for binary programming is essentially the same as the networking because, again, everything works off of itself. Everything works itself off of binary. That's how they're all connected. And all the programming is just a way to even package the security, get the firewalls up, make it so that way things are easily recognizable and stoppable. So I chose blockchain as my up and coming situation, mainly because crypto is kind of huge. I know it's dying out, but people really like it still for some reason. Um, Essentially, so what it does is it takes away, uh, it allows people, it decentralizes uh, information and puts them in easily digestible chunks that are easily visible for everybody to increase trustworthiness and reliability on a product. Um, we also have, it also increases, digital identity, intellectual property. It can also influence voting. It can be used in a lot of different ways. Ethically, it's transparent, so people want to trust it. It does work with finances. It does give people the sense of empowerment and feeling good about themselves. It does reduce censorship, but it does have a huge environmental impact because it is directly connected to large buildings, things like that. Needing lots of electricity and carbon emissions. It can be used illicitly, which it has been in the past, which is where crypto came from in the first place. Uh, its immutability as is a flaw of itself. Nothing can be changed once it's in, it's in. And if you're wrong, too bad. Um, uh, the code is the law, not the ethics. So whoever's writing the code is kind of the rule, judge, jury, and executioner in this case, and it's inequality and speculation. So, in conclusion, at its most fundamental level, computing is built on binary. The symbol zeros and ones represents all electronics programming, organizes everything complex into simple data structures and easy to see things. The binary function foundation is extended across all technology at all times. And blockchain is an evolutionary project process that's coming about, and I really learned a lot in this class, and I can't even try to say everything that it is. So that's my project. I hope you liked it. And thank you. There you go.